In this video, we are going to look at factorizing special binomial products. First is factorizing by grouping in pairs. So it's an extension of factorizing algebraic expressions. So let's look at example 1, factorize each expression. Now, if you look at this example carefully, you can factorize the first two terms. Then you can also factorize the last two terms. So if you look at the HCF, highest common factor of 6ax and 9x is 3x. So I can write 3x outside the parenthesis. Divide 6ax by 3x. That gives you 2a. Then minus 9x divided by 3x is 3. Now, highest common factor of 8ay and 12y is 4y. So I write 4y here and then the parenthesis. That gives you 8ay divided by 4y is 2a. And then 12y divided by 4y is 3. Now, if you look at carefully, we have this parenthesis common in both terms. So actually, we have two terms now. So term 1, term 2 separated by plus sign in between them. Now the common between these two terms is that parenthesis. So I take common. Then if you divide the first term by 2a minus 3, we are left with 3x. If you divide the second term by 2a minus 3, we are left with 4y. Now, there is nothing common between the terms of each grouping symbol. So that's your final answer. Part B. Again, look at this expression in pairs. So the highest common factor of 3x squared and 9xy is 3x. So write 3x outside the parenthesis. 3x squared divided by 3x, x. 9xy divided by 3x is 3y. And the minus sign comes from the in between sign. Now, remember when we did previous factorization, if the first term is negative, we take the negative factor out or negative term out. So in this case, the highest common factor of negative xy and 3y squared is actually negative y. So I write negative y outside the parenthesis sign. Now xy divided by y is x. And if you take a negative factor out, the sign inside the bracket parenthesis will change. So 3y squared divided by y, and the sign will also change, so which is 3y. Now again, look at two terms, term 1, term 2, separated by negative sign in between. The common factor is x minus 3y. Now we are left with 3x and minus y. Now nothing more common, so that's our final answer. Now this is easy. We can see there is common, but not exactly. Now we can make some changes. In the first term, the parenthesis has a minus b. In the second term, parenthesis has b minus a. They are not exactly same, but we can make some changes. So I can take negative sign common from the parenthesis. That makes minus y. And now this, so b, it instead of just b, it will be negative b, and instead of negative a, it will be positive a. So I can swap them around and I can write a minus b. Now we can clearly see the common factor is a minus b. We are left with x and negative y. Nothing more common, so that's our final answer. Now, again, look for first two terms and the last two terms. Highest common factor of first two terms is y, and we are left with x and one of the y's. So that gives you x plus y. Now here both are, there is no number common. If nothing is common, it means one is common. But because the first term is in the second pair is negative, so I should write negative 1 outside the parenthesis. Then negative x divided by negative 1 is x. Negative y divided by negative 1 is plus y. Now we can clearly say we have x plus y common, and we are left with y minus 1. Part E. Actually, we have three pairs now. And we need to look carefully. If we take something common, do we get any common expression? So if you take x outside, you get a plus b. Here you put y outside, again you get a plus b. Here you put z outside, you get again a plus b. Now the common factor is a plus b. And we are left with x plus y plus z. Nothing more common, so that's final answer. Now we need to look at factorizing the difference of two squares. We have already done x plus y times x minus y is x square minus y square. And you know that factorizing is the reverse process of expanding a product. Factorize x squared minus 9. Can we write this as a difference of squares? Yes. X squared minus 3 squared. And if you can write as a difference of squares, then you can easily write, set it out first. Write x plus 3 in the first parenthesis, x minus 3 in the second parenthesis. It doesn't matter whether you write with plus in between first or minus sign in between them. 9x squared minus 16 can be written as 3x whole square minus 4 square. Again, it's difference of squares. Set it out first. In the first parenthesis, I can write 3x plus 4. Second parenthesis, 3x minus 4. Part C. Yes, can we write it as difference of squares? So ax whole square. 16 is the square of 4. So 4by whole square. Set it out first. You get ax plus 4by, ax minus 4by. Now, this is a tricky question. We can write this as difference of squares. So I can write this x to the power 4 as x square to the power 2, y square to the power 2. Now set it out first. X square plus y square, x square minus y square. Now it's still not completely factorized. We cannot factorize x square plus y square further, so write this as it is. However, we can factorize x square minus y square, which is again a difference of squares. So I can write x plus y times x minus y.